Hi students, today I am going to explain valency shell electron pair repulsion theory. It is also called Vesper theory. So, it is developed by Gillespie and Nylom in 1957. So, what is this model? This model is to use to predict the shape of individual molecules based upon the extent of electron pair electrostatic repulsion. So, this is the model. So, to explain the covalent molecules, how the covalent bond is formed, how the bond angle will be because of the electrons. So, we know that covalent bond is formed by sharing of electrons. While sharing of electrons, what happens? How much extent this electron pairs will repulse, so that the shape of the individual molecules will depend on it. So, according to this theory, so shape of the molecule depends upon the number of bonding electron pairs and non-bonding electron pairs in the central atom. So when we see, so we know that two atoms, so when they combine with each other by sharing of electrons, then a covalent bond is formed. So there will be two types of electron pairs. We know that bonding electron pairs and non-bonding electron pairs. Bonding electron pairs means which will share the electrons. So, and non-bonding electron pairs are already paired and they will not be participating in the bonding due to the bond formation of the central atom. So, because of these two electron pairs, bonding electron pairs and non-bonding electron pairs, the shape of the molecule will depend. So, the central atom is oriented in such a way that there is minimum repulsion between bonding electron pairs. So, we know that electrons are negatively charged ions, or electrons are negatively charged particles, and when the two atoms combine with each other, because of sharing of these electrons will come together. So, because they are both are negative, so they will repel each other. Because of this repelling, the bond angle which should be there, it will be changed. So, the central atom's orientation will be how it will be, so that there will be a minimum repulsion between these electron pairs. And it is basically a model to predict the geometry of molecules, how the molecules geometry will be there. So it is explained in this model by valency shell electron pair repulsion theory. So what are its postulates? So these postulates are the rules how the molecules will be there and how their shape will be there, stability, how it will be there. So first is, if the central atom in a molecule is surrounded by only bonding electron pairs and not by non-bonding electron pairs, then it will have regular geometry or shape. So the central atom, if it have only bonding electrons and it don't have lone pairs or non-bonding electrons, then the shape will be regular geometry, and so the shape will be in regular shape. And so when we see, there are two types of atoms. They both are forming the covalent bond by sharing of electrons, for A and B. So A is the central atom and B is the outer atom. Let's think. And what is its general formula? A, B, N. So N is the number of number of outer atoms. So A, B, 2. So when the central atom is A connected with two B atoms, so then the shape will be linear and the bond angle will be 180 degrees. So example of this is BeCl2. So Be in the middle with two chlorine atoms. Then Ab3. So Ab3 is central atom A with connected with 3 B atoms, and it is in a trigonal planar shape. And the example is BeCl3 and the bond angle is 120 degrees. Then Ab4, it is having 4 B atoms connected to the central atom, and it is in tetrahedral shape, and example is SnCl4, SN middle, 4 Cls attached to it, and the bond angle is 109.5 degrees centigrade, 5 degrees. Then AB5 is trigonal bipyramidal shape. See here, trigonal bipyramidal. So it is like two pyramids, trigonal bipyramidal, and so the bond angle here is this from this B to this P is 90 and 120 also. So they are having two angles 90 and 120. And so for example of this is PCl5. Then AB6. So central A atom is connected with 6 outer atoms and the bond angle is 90 degrees centigrade and it is having octahedral shape. Example of this is SF6. So this is the first postulate. If no non-bonding electrons, so no lone pairs, only bonding electron pairs are there, like this the shape will be, and it is a regular geometry. So what happens when the lone pairs are there? It is explained in the second postulate. If the central atom is surrounded by both bond pairs and lone pairs, then the molecule have distorted or irregular geometry. So when the lone pairs are also there, then the molecule's geometry will be distorted or it will become irregular shape, because lone pairs, what it will do, it will repel more strongly than bond pairs, because of more repulsion of lone pairs than bond pairs. So what happens, the geometry or the shape will be changed, and because of this bond angle also decreases. So let's see how. For example, so we will see molecular geometry when central atom has lone pairs also. So A is the central atom, B is the outer atom as we know, and E are called lone pairs. So let's see first AB3. So it is having, we know that trigonal planar shape and 120 degrees, we know that, we studied. Then so if one B atom is replaced by one lone pair, so it will become AB to E. So and so here see, so one lone pair it is replaced in the place of one B. So what happens, the bond angle decreases to less than 120 and the shape is changed from trigonal planar to bent or angular shape. See here, bent or angular shape. Like this the shape is distorted and the bond angle is decreased. So when tetrahedral shape, in the case of AB4 we know that so one B atom is replaced by lone pair E, so it will become AB3E. So when 2, then AB2E2. Let's see. So the normal shape of tetrahedral AB4 is tetrahedral shape and bond angle is 109.5 degrees centigrade. So if one B is replaced by lone pair, then the bond angle decreases to less than 109.5 degrees and the shape will change to trigonal pyramidal. And so if two B atoms are replaced, then again the bond angle will decrease to 109.5 degrees 5 degrees and the angle will be bent or angular. Like this it will shape. The shape will change. Then next is AB5. Its shape is trigonal bipyramidal. So if one B atom is replaced, then it will become AB4E and bond angle will be less than 90 and 120. Let's see here. So here it is 90 and 120 I told. So when one B atom is replaced, so the bond angles will decrease the less than 90 and the shape will be seesaw shape. So if two B atoms are replaced, so if two B atoms are replaced by two lone pairs, then it will become AB3E2 and the bond angle also decreases and it will take the shape of T shape. See, T shape. Then again if three B atoms are replaced by three lone pair of electrons, then lone pairs of electrons, then what happens? So the AB2 molecule, AB2E3 molecule will take the shape of linear and the bond angle will become 180 degrees. So then next is AB6. We know that it is having a octahedral shape. So let's see. So what happens if B atoms are replaced by lone pair of electrons? Let's see. So AB6 it is having 90 degrees and octahedral shape. It is arranged when one B is replaced by a lone pair, then what happens? It will take the shape of square pyramidal. So it will take the shape of square pyramidal and so the bond angle will be decreased to less than 90 degrees centigrade, 90 degrees. And when two B's are replaced by two lone pairs of electrons, then it will become square planar. So and the bond angle will be less than 90 degrees. So next, what are the limitations of Vesper theory? So it did not explain the shape of the molecules being polar bonds, having polar bonds. So this theory did not explain the shape of the molecules having polar bonds, and even it did not explain the shape of the molecules which are extensively delocalized pi electron system. So and it did not explain the shape of the molecules having inert pair of electrons. So and also it did not explain the shape of certain compounds of transition metals also. These are the limitations of this theory. Thank you.